Good morning. This is your stat sensei, Mr. Spensei, and we're going to do a warm-up on hypothesis test. So a candy machine is supposed to fill bags of candy with an average of 19.2. So all right, that's probably really important. The machine has a standard deviation of 0.1. So this is the population standard deviation. This didn't come from a sample. A random sample of 32 bags out of a batch of 5,000. So in other words, we have a population of 5,000 and we have a sample size of 32 was selected and a sample mean of 19.25 ounces was collected. So this is my sample mean. So this is my X bar is 19.25. Test to determine whether the amount of candy in the bag is different than 19.2. All right, that's a key word. Write the hypothesis and define the parameter and write the conditions. All right, so let's start off by writing our hypothesis. Well, all hypotheses, when we're dealing with means, start off with mu equals something. Well, the mean is supposed to equal an average of 19.2, so 19.2 ounces. All right, the alternative, well, it's going to be mu, it's going to be 19.2 ounces. But we need to read carefully to determine whether it's a less than, greater than, or not equal to. Well, we circled the word difference, which means not equal to. So they're looking to see if it's different, whether it could be more, it could be less. They just want to know if it's different. The next thing is define the parameter and write the conditions. So let's go ahead and define our parameter. Our parameters always starts off with, or at least for mean, let mu equal the true population mean. And what are we looking for? Weight, because it's measured in weight of candy, right? So true population mean weight of candy, technically in the bag. You know what? In a bag. There we are. So now we have it in complete context, which is important. So now we need to do our conditions. And the first condition is random sample. So we'll need to check this, go back and we'll read quickly and see whether or not they said random sample. And so a random sample, yep, there's random sample of 32. So 32, that's our size. And that was given, so we can just put a check mark. The next thing, we need to check the n is less than 10%. So n equals 32. We are always multiplying by 10. So 32 times 10 equals 320. And what's my population size? Well, they had 5,000 in the batch, and 320 is less than 5,000. So we're good there. The next one is our normality. Well, they didn't tell us the shape of the distribution. We don't know if it's skewed, bimodal, what it is, but our sample size is 32, and that's greater than 30. So normal by central limit theorem. And really, it's approximately normal. And if it's an AP, you need to write approximately normal. All right. Even though this just said write the hypothesis and parameter, I'm going to go ahead and set up the test for us. This would be a z-test because the population standard deviation is known. So z equals x bar minus mu standard deviation divided by the square root of n. And we're going to want the probability that z, and I notice that 19.2 is larger. I mean, that 19.25 is larger. So I'm going to use a greater than symbol, 19.25 minus the 19.2 over, and my standard deviation is 0.1 divided by the square root of 32 But because this was a not equal, and anytime we have a not equal, this needs to be 2 times. So we need a 2 times out here, 2 times that probability. All right. Hope that helps, and we will see you on the next one. Thank you.